So we're going to start out by defining the tangent line geometrically. So I've got the unit circle drawn out here, and I have the cosine sine values labeled and also the tangent. So let's just briefly review. The cosine is the length here on the bottom of the triangle, which gives this point A an x value of the cosine theta. Sine here is the measure of the height, which gives this point A a height value of the sine of the angle. So what's tangent? Well, if we draw a line over here, so see this line? If we draw a line that is tangent at this point B, okay, hence the name tangent. So here's tangent. Tangent is going to be the following. Now I'm going to drop the bottom part of that line out there. So but if you see this green length up here at the top, the length from here down to here, that length is the tangent of the angle. So the tangent goes from here down to here. Okay, now take a look at this visual. What we're going to do is we're going to enter in an angle value, let's say 30 degrees. It's going to draw the angle, and now if you see over here this vertical line that goes up and down, what we'll do is we'll extend our angle out, the terminal side of the angle, out to this line. Its intersection will hit somewhere along the line, and then that length back down to the x-axis is the tangent value of that angle. So here we'll put a 30-degree angle in. We'll draw the terminal side out. Where the terminal side hits that line or intersects, that length right there will be the tangent value. So let's go a little bit higher. We can go up to 45 degrees. Notice that it hits obviously higher. We can go to 70 degrees. And we're going to hit much higher. Now if we extend that further, let's maybe go to 80 degrees. You can tell that our tangent values are going to get much larger. Okay, see, so we're going to intersect much higher up, so the tangent values are going to increase very quickly as we approach 90 degrees. So let's do 88 degrees. Maybe this example's overkill, but notice that by getting closer and closer to 90 degrees, that tangent value is going to get much larger. In fact, if we go exactly to 90 degrees, what will happen, let me scale this back down here. Here's a 10-degree angle. But if I go to 90 degrees, what's going to happen is my angle, the terminal side of my angle, will be parallel to this tangent line. So there will never be a place where at 90 degrees we intersect this tangent line, which means that we can't have a tangent value at 90 degrees. Since there's no intersection, it's undefined. In fact, if we go all the way around to 270 degrees, the same thing will happen. Now watch what happens if I go more than 90 degrees. So now, more than 90 degrees means I'll intersect over here in quadrant 2. Now where do we draw the connection? Well, you might say, well, that's never going to intersect this vertical line. But we can draw the angle backward down the other way, and you'll see that it'll intersect in a negative position. So let's go to 120 degrees. So I'll rotate around, and now it'll be drawn backward. So here's my angle, and I'm going to extend the line back down and to the right. And so it's going to give me this tangent value that's negative. Okay, if we go over to 150 degrees, again, our intersection is going to be negative. If we go to 180 degrees, that intersection value is going to come straight back, and we're going to get a tangent value of 0. If we get down to quadrant 3, let's say 210 degrees, the same thing's going to happen. We're going to come back on the angle, and we're actually going to intersect up in quadrant 1. Okay? And of course, if we go down to quadrant 4, we're going to intersect down there in quadrant 4. So let's say 330 degrees. And there's our value. So that's one way to look at the tangent function, is to look at this graphical representation on the unit circle.